May 16, 1945, at Chobham Heath in Surrey, England. A stopwatch stops at 4.2 seconds. That's how long the captured German armored car takes to reach 50 miles an hour on the test track at the fighting vehicle, Proving Place, Captain James. Thornton looks through his binoculars as 12,700 pounds of diesel power and welded steel rush past the post with 8 wheels gripping the ground. The top speed is 56 miles an hour, and the range is 620 miles. The Americans say it is the most advanced wheeled combat vehicle they have ever seen. Then Thornton's team fires one .50 caliber bullet at its side, and it goes right through both walls of the fighting area. They check the armor with tools. It is only 8 millimeters thick, about as thick as 2 pennies. A Bren gun could destroy it. The Germans made a vehicle so fast and strong-looking that soldiers could not resist using it. The wrong way, it had speed, but no real protection it carried. A 75 millimeter gun behind armor thinner than a soup can, and from Normandy to Berlin, battle reports showed a lesson about the price of being too clever without balance. Now the 8-wheeled machine sits still on the concrete floor at the testing ground 15 miles southwest of London, marked as the Sokolov's 2343. This name means nothing to most British soldiers, but to the smart officers at the war headquarters. This vehicle is the top prize taken in the last days of the war. In Europe, American troops had found it near Dessau on April 23, 1945, left behind by its crew with 3/4 of a tank of fuel and 320 shells, all safe. Inside, it was still working fine with no battle. Harm a rare lucky find that might happen twice in a whole war. When the vehicle reached Churchy on May 3rd, Captain James Thornton had already read the early U.S. reports, and since American experts never exaggerate their words, surprised him. They said it was the most advanced wheeled combat vehicle they had ever seen. Thornton had led Daimler armored cars in North Africa, so he knew what the word advanced really meant. Fast, tough, dependable, and able to survive in desert heat that destroyed most other machines. The Germans were known for building machines that were often too complex, but if the Americans were amazed, then there was something here worth studying. The test plan said the team would spend 6 weeks checking everything, like how well it moved, how the engine worked on different kinds of ground, how the suspension bounced, how far it could stop, how tightly it could turn, how fast it could go across rough land, all those usual checks that told British designers what the Germans had made, and if any ideas were good enough to copy, then came the armor tests, and that changed everything for Captain Thornton. Sergeant Thomas Webb took out the calipers himself. He had checked armor on many captured vehicles before, and always worked carefully. The front armor slanted 60 degrees from straight-up measured 30 millimeters thick fare for a scouting vehicle, not enough to block tank guns, but okay against bullets and flying metal pieces. Webb moved to the side. He placed the calipers on the steel walls, adjusted the tips, and read the number 8 millimeters. He checked again in another spot. 8 millimeters. Again, he checked once more. Higher near the fighting part. Still 8 millimeters. Thornton watched Webb's face as the man looked up calm and steady, like someone who had learned from surviving a burning Churchill tank. That armor was not just a number on paper, but what decided if you lived or died. Webb said nothing. He just lifted 8 fingers. The room went quiet. 8 millimeters meant the side armor was only as thick as 2 British pennies stacked together. Thornton told them to test the other side, too. Same result, the Americans had already done live shooting before sending the vehicle. To England, their papers had pictures 50 caliber armor-piercing bullets fired from 400 yards. Every shot that hit the side went straight through one hole in and one hole out, cutting clean through the spot where the crew would sit. Webb went to the weapons room and brought back a boy's anti-tank rifle, a gun that by 1945 was nearly out of use, too weak for newer tanks, and kept only for special tests. Mostly, the gun was used in training groups by then at 200 yards. Webb fired one shot at the Puma's side, and the bullet went right through one wall, crossed the whole fighting space, and came out the other side, leaving two clean holes with sunlight showing through this old weapon that British soldiers, hardly trusted anymore, had just shown it could destroy this vehicle from either side. Thornton walked slowly around the Puma, looking carefully at the shape of the body, the setup of the wheels, and the design that made it look full of power in such a small frame. The front armor told a different story than the sides. It was 30 millimeters thick, nicely slanted, strong enough to block small bullets and flying metal pieces from the front. It was a tough target, but once it turned to move, the sides were open to even a Bren gun. Then, Thornton looked at the main gun, and the strange mix of ideas became clear. The 75 millimeter K51 L-24 howitzer was placed in an open-top fighting area that could only move 20 degrees in total, 10 left and 10 right, to shoot at anything outside that narrow space. The whole 12,700-pound machine had to turn in real battle. That meant it had to keep moving all the time, showing those thin 8mm sides again. And again the gun could fire explosive shells that tore apart soft targets and could break light armor up close. But each time the crew aimed at something, they turned their weak sides toward whoever was shooting back. Thornton had spent 3 years wondering if following orders instead of taking risks could have saved his troop leader near Tobruk in 1942. Scouting rules were simple: watch and report. Do not fight, and use your speed to get away. His commander had told their Daimler armored cars to fight German half-tracks, and though it worked, and they destroyed 2 enemy vehicles, then German backup forces showed up carrying heavier weapons, and Thornton's commander died because he had stayed to fight a battle that scouting units were supposed to stay away from. The Puma showed that same dangerous temptation turned into a machine. It had speed, but not safety power, but no lasting strength. The Germans had made a vehicle so strong, so fast, and so armed that its crews would find it almost impossible to follow the safe rules that could keep them alive when you drove something that could hit 56 miles an hour, move backward as fast as forward, and fire a gun that could blow up enemy vehicles. You would feel like fighting, not running, and those thin 8mm sides meant that feeling could kill you. From that moment, Thornton's mission changed. This was no longer just a test. It was a search for a truth hidden inside the 470. 8 Sd.Kfz 234s built between 1943 and 1945. A truth about how far invention could go before it became deadly. The lesson about brilliance without balance. And it was his job to find it and write it down before the next scouts learned it by dying the hard way. The Sd.Kfz 234 project had started in August 1940 as an answer to a big problem south of Berlin. The North African desert was destroying German armored cars faster than the battles were. The old Sadov Zawos 231 8-wheeled cars had seemed fine in Poland and France, but Libya and Egypt showed every weakness. Their gasoline Hork engines overheated in 120-degree heat. Their air-cooled parts could not get rid of the heat fast enough, and the fine desert sand got into every bearing seal and moving piece. The Africa Corps scouting units reported that more than 40% of their cars were breaking down. The few still working spent more time in repair shops than on patrols. In September 1940, senior engineer Wilhelm Voss got the new design order from the Army Weapon Office. The new requirements were bold for that time. it needed an air-cooled diesel engine to save fuel and lower fire danger. A monocoque body, where the armor itself worked as the frame cutting weight and giving better safety, and an independent suspension with at least 8 inches of wheel travel to cross rough desert land that broke other vehicles. It had all-wheel drive and all-wheel steering to move easily on any ground. It could travel 1,000 kilometers on roads and 600 across open land. These plans asked for a kind of vehicle that did not exist anywhere. Yet, Wilhelm Voss was a car engineer, not a weapon maker. His special skill was knowing how all parts could work together. Instead of separately, he chose the Tatra 103 air-cooled diesel V12 engine for power, with 14.8 liters and 210 horsepower. The engine came from Czechoslovakia and had already worked well in trucks from icy Arctic weather to hot tropical climates. Voss connected it to a gearbox with 6 forward and 6 reverse speeds, all at the same ratios, so the vehicle could back away just as fast as it could go forward. This smart idea later saved many crews when they had to pull out of surprise fights. The suspension was Voss's biggest improvement. Each of the 8 wheels was set on its own swing arm with coil springs and fluid shock absorbers. This gave each wheel about 8 inches of up and down movement, letting the vehicle stay fast on rough ground that slowed other cars to a crawl. With 8 wheels, it could still move even if 2 were damaged, and with 8-wheel steering, it could turn in a tight 42-foot circle. By July 1942, the test model had proved everything. The Tatra engine ran smoothly in freezing -40-degree Russian winters and in desert heat above 50 degrees Celsius. The 8-wheel setup climbed steep slopes that other vehicles could not, and it could cross water more than 3 feet deep without help. The monocoque body saved hundreds of pounds of extra weight while making the frame even stronger. During tests at Kummerdorf, south of Berlin, the prototype kept speeds over 50 kilometers per hour on ground, where other armored cars barely reached 30. But by the time it was ready to build in numbers, the war in North Africa was falling apart. Rommel's push had stopped at El Alamein in November 1942, and by May 1943, the Africa Corps had given up. The place this new machine was made for no longer existed. By the time it was ready, the Sakoyev 234 had been built for wide-open desert fighting, but the first ones rolled out of the Busingnag factory in September 1943 into a totally different kind of war. Now the battles were not in endless sand, but in the tight fields of Normandy where hedges blocked the view, and fights happened only a few hundred yards apart. They were in the broken cities of Italy, and later inside German towns, where armored cars faced soldiers with rocket launchers at point-blank range, and in the deep mud of the Eastern Front, where roads vanished and only good off-road movement kept you alive and out of traps. 4 main versions were built using the same base frame. The 2341 had a 20mm autocannon in an open turret. About 200 were made. The 2342, called Puma, got a fully covered turret with a 50mm gun, and 101 were built. The 2343, like the one sitting at Churchy, carried a 75mm short howitzer in an open-top space. 88 were made, and the 2344 replaced that with a longer 75mm anti-tank gun. 89 built in all. Only 478 vehicles were ever made. The numbers told their own story. American factories built more than 8,500 M8 Greyhound armored cars. At the same time, the Soviets made over 9,100 BA-64s, and British plants turned out 5,400 Humber cars. The Sakoyev 234 was the best German wheeled combat design ever created, but there were too few to really matter. Voss watched these low numbers with growing frustration. His design had done everything it was meant to do. Every goal had been met or passed. The Tatra diesel was tough. The suspension could cross. Any ground the eight-wheel drive gave a freedom to move that no Allied vehicle could match. But the Army got them a year and a half too late, and the changes made along the way turned it into something else. The Puma's 50mm gun could pierce 60 millimeters of armor at 500 meters, enough to smash through the side of a Sherman tank, hit the flank of a T-34, or punch the back of a Churchill. The version with the PaK-40 gun could even destroy heavier tanks from far away, but that power made people use it the wrong way. Every army taught the same basic scouting rule: watch and report, don't fight, unless you have the perfect chance, and if you shoot, leave fast. But when a crew sat inside a machine that could blow up enemy tanks, those rules were hard to follow. The urge to fight became too strong. The 50mm gun that was supposed to save them in danger made them stay and battle when they should have escaped, and when they stayed, those thin 8mm sides that Voss had designed for a vehicle never meant to fight could not protect them from enemy fire. Voss had fixed the desert problem perfectly. He had built the most advanced wheeled combat car in the world, but the war had changed, and the new updates made it far more deadly to its own men than to the enemy. Thornton's team ran 47 tests over 6 weeks. Starting in mid-May 1945, they followed the standard test plan used for years on captured enemy vehicles first. They tested how it moved, because once they began shooting its armor, and parts would be damaged and could not be checked again. The speed tests were done on a set 1/4-mile stretch of smooth road, with timing marks every 50 yards. Sergeant Webb drove, and Thornton used a stopwatch to record times 0 to 50 miles an hour. Took 4.2 seconds on dry road. They did it again on grass, and it took 7.8 seconds. That showed how well the eight-wheel drive shared power on different surfaces. Most four-wheel drives lost more time because two wheels would just spin while the others had to drag the full weight. But the Puma's system kept all 8 wheels gripping the ground, no matter what. They drove on next. They tested braking from 50 miles an hour. It stopped in 127 feet on pavement, with the driver pressing the brake pedal as hard as he could. The 2344 used German hydraulic brakes with drums on all 8 wheels, each one cooled by airflow built into the wheel spaces. British Scout cars usually had only 4-wheel mechanical brakes, and that difference showed in the tests. A Daimler armored car needed about 170 feet to stop from the same speed, while the Puma did it in much less. The turning circle at full lock was 42 feet, measured from the center to the outer edge of the outside wheels. The 8-wheel steering made the back wheels turn opposite the front ones, so the vehicle could turn much tighter than its size. Made you think possible. Webb showed this by driving the Puma through a line of cones spaced so close that a normal car would have to stop and back up. But the Puma moved right through with no pause. The back wheels moved inward as the front wheels swung out. Next, they tested it on a 10-mile trail across Chobham Heath, made to copy all kinds of battlefield ground, with slopes, stream crossings, loose sand, sticky clay that trapped anything when wet, and shell craters left from training. It was a hard course on purpose, because scout cars that were fast on roads but weak on rough land were worthless. The Puma finished the whole course at an average of 31 miles an hour, even counting the hardest parts. Webb said the shocks took hits that would have slammed the springs on a Daimler flat, and the diesel engine stayed cool, even when pushed hard for a long time. Thornton then ran the same tests with British cars to compare. A Daimler armored car that weighed 7,600 pounds with 4-wheel drive and a 95-horsepower motor did 0 to 50 miles an hour in 8.9 seconds on pavement, and only averaged 18 miles an hour cross-country. The Daimler was known as one of Britain's best scout cars, tough and trusted by its crews, but the Puma's results were on a whole different level of performance. The Humber Mach-4 could not finish the cross-country course at all. It weighed 7,100 pounds, had only rear-wheel drive. The suspension hit bottom again and again on rough ground, and the vehicle got stuck 3 times in soft mud, where the Puma had driven through without slowing. Thornton wrote this down in his report. British scouting rules assumed roads would be there, or at least ground. You could drive on the German car, did not expect that next came the armor shooting tests, and the Puma's clear advantage turned into a much darker result. Webb set up firing positions at measured distances with sandbag rests to remove shooter error. They were not testing skill, but finding exact numbers for what weapons could do to certain armor thicknesses. They began with normal infantry guns and moved up to stronger weapons, a Bren light machine gun firing normal ball ammo at 200 yards, left marks on the side armor, but did not go through the plates. The rounds did not have enough force to punch through 8 millimeters of steel when the Bren used armor. Piercing rounds at the same distance, it made a clean hole. The hard core of the AP bullet went through the side and would have gone through the fighting space to the other side if the test had continued. Infantry squads across the British Army carried Bren guns as their main support weapon, which meant the Puma could not survive meeting regular troops if they had the right ammo. Webb then tested the Browning M2HB 50 caliber heavy machine gun, the common vehicle weapon on American armored cars, armor-piercing rounds at 400 yards completely passed through both side walls. The entry hole was about ½ an inch, and the exit hole was larger. From metal breaking and bending, anything between those 2 holes would be ruined. Equipment shells and crew, the boys' anti-tank rifle. Test was almost not needed by then, but Thornton wanted the full set of tests, so Webb fired 1 single shot at 200 yards, single shot. The round went straight through the side armor and caused heavy spalling inside where bits of steel broke off and turned into flying metal that could badly hurt anyone sitting nearby, even if the main shot missed them. The next test used the 37mm M5 gun found on American Stuart light tanks at 600 yards with M51 armor-piercing shells. The round went clean through the side and still had enough force to pass through anything inside and out. The other side, this proved again what the earlier tests had shown. The Puma's side armor could not stop anything bigger than rifle bullets on a real battlefield. It might as well have been thin sheet metal. The open-top fighting area of the 2343 made things even worse, in ways numbers could not explain. Artillery blasts in the air would rain sharp metal on the crew. Mortar shells close by would do the same. Hand grenades and gunfire from above. Like buildings or hills could all hit the open crew. Normal small arms fire that a closed car would block could easily kill when the men sat behind only 14.5 millimeters of short armor around the gun position, Thornton wrote in his early test notes. Heavy weapon plus weak armor equals a tactical trap that leads to misuse. He did not have to explain what that meant. The officers reading knew at once. The car was so fast, so strong, and handled so well that soldiers would be tempted to use it to fight instead of scout. Every skill it had pulled its crew toward battle. And once they fought, they were exposed. Exposure meant getting hit. Hits meant holes. Holes meant dead crews who trusted their car to save them when orders said not to fight. Battle reports started reaching Churchy in early June as British intelligence gathered German unit files taken in the last weeks of the war. Thornton asked for every report that mentioned the Sd.Kfz 234 in front line use. What came back was a long list of smart tactics that all ended the same way, in total failure. The same story repeated again and again, with different units in different places. and battles in July 1944, the Panzer Lehr Division's scout group was near Tilly-sur-Seulles in Normandy, 3 Sd.Kfz 2342. Pumas were moving ahead of the main force when British Cromwell tanks started coming down a narrow road. The Puma commander hid his cars in a tree line where they were well covered, but could see clearly across 800 meters. The first Puma fired its 50mm armor-piercing shell. It hit a Cromwell in the side, and the tank blew up. Its shells cooked off in thick black smoke. It was a perfect scout ambush. They saw the enemy first hit from cover and destroyed their target, just like training said. But the Puma crews did not pull back. Orders said to leave right after firing to get away fast before the enemy could spot and shoot back. The commander had already done his job. He proved the British tanks were there and could be hit from the flank. That should have been the end. But instead he told his other 2 Pumas to keep firing. They hit 2 more tanks. One stopped, the other kept moving. The British gunners turned toward the trees and started blasting with their 75mm guns. They could not see the Pumas, but they could see where the flashes came from. They fired one shell after another into the trees. High explosive rounds blew up in the branches. One shell hit low, went through the trees, and straight into a Puma's side. Armor, the 75mm shell tore through the thin 8mm plate, and the car exploded when its shells went off. Another round hit the second Puma with the same deadly result. The last Puma tried to back away, but turned sideways and got hit by 2 rounds at once in 4 minutes. All 3 Pumas were gone. The German report said 8 men killed and 3 hurt. Every Puma destroyed. The British losses were none. 1 Cromwell destroyed, 2 damaged but repairable. The reconnaissance unit had traded 3 advanced vehicles and 11 trained crew members. For a tactical victory, that meant nothing because none of them survived to report what they had learned about enemy strength and dispositions. Eastern Front, January 1945, 2nd SS Panzer Division, Das Reich, operating in Hungary during the German Sd.Kfz counter-offensive toward Budapest, Sd.Kfz 2344 variant, mounting the long 75mm PK-40 anti-tank gun. The crew encountered a Soviet IS-2 heavy tank advancing alone, separated from its supporting infantry. Perfect ambush conditions. The Puma positioned behind a destroyed building with only the gun barrel exposed, range 400 miles. The crew waited until the IS-2, in a 2 feet T2, presented its flank, single-shot armor-piercing round striking just behind the turret. Penetration into the engine compartment. The IS-2 stopped. Smoke pouring from the rear deck. The Puma crew reported their kill by radio. They should have withdrawn immediately. The IS-2 was disabled. Mission accomplished, but they remained in position, apparently believing the destroyed building provided adequate cover. Soviet infantry responding to the disabled tank spotted the Puma's position. They did not have anti-tank weapons heavy enough to defeat the frontal armor. They used what they had, 7.62 mm Hirturauders, machine guns and rifles. The open-topped fighting compartment meant the crew was exposed to any fire coming from above. The Soviet infantry took positions in the upper floors of buildings overlooking the Puma's location and fired downward into the fighting compartment. The after-action report noted that the vehicle itself was recovered intact with minimal damage, but all 4 crew members were dead from small arms fire that had come through the open top, a vehicle capable of destroying. The most heavily armored tank in the Soviet inventory had been defeated by infantry with rifles because it stayed in position 20 minutes too long. The pattern emerged clearly as Thornton worked through additional reports. German reconnaissance. Doctrine was explicit and detailed. Observe and report. Avoid engagement unless ambush conditions are perfect. Use speed to disengage immediately after firing. Fire 1 shot, maybe 2, if the situation allows, then withdraw before the enemy can locate, and return fire. This hard-learned lesson cost lives and changed how crews would be trained going forward. The doctrine made sense. It came from hard lessons in Poland, France, Russia, and North Africa. Every good reconnaissance officer knew it, and every training book taught it, but the Sd.Kfz 234, especially the Puma and the PAK 40 version, made it almost impossible to follow. When you drove a machine that could destroy enemy tanks, when you had just proved your gun could punch through armor, that others said was too strong when you saw more targets and knew you could hit them. It was too tempting to stop. The pressure to take one more shot, one more kill to stay, just one more minute because you thought the enemy hadn't seen you yet, was too strong, and that one more minute was when you died. That was when the 8mm anti-side armor stopped being armor and became just thin metal that couldn't stop anything bigger than a rifle bullet. The Puma's best thing, its 50mm beat-em gun, became the reason its crews were killed. That power made them fight longer than they should. Firing meant staying still. Staying still meant the enemy could aim back. And when the enemy fired at 8mm of steel, the result was always the same. Of the 478 Sd.Kfz, 234s ever built, about 320 were lost in battle crews. In frontline scout units usually lasted weeks, not months. Some groups lost every Puma they had in their first month, not because the machines broke down or were badly designed, but because the Ibuig men couldn't stop using them in ways that made them easy to kill. Thornton read the reports slowly, underlining the parts that showed the truth. The Germans hadn't failed at building the vehicle, and they hadn't failed in writing the rules. They failed to understand people. You can't give soldiers a tank killer and expect them not to use it. You can't make a vehicle so fast and powerful that it feels untouchable and expect its crew to remember. It's not. Capability built confidence, and confidence killed them. Confidence led to engagement. Engagement led to casualties that the rules were supposed to stop. Thornton finished his evaluation report on June 28, 1945. 127 pages, with 34 photos, 18 technical drawings, and 47 tables of test results. The report would be kept secret and sent to top officers at the War Office, technical experts at the Fighting Vehicle Design Center, and intelligence officers at SHA headquarters who were making full reviews of German military technology. The conclusion section was 3 pages long. Thornton knew from his time in North Africa that senior officers rarely read past the summary, so the key points had to be at the start and written clearly enough that nobody could misunderstand or ignore them. He wrote in the calm British style that avoided exaggeration, but the words carried weight. He wrote, "While the Sd.Kfz 234 series shows excellence in engineering design, suspension systems, and powertrain integration, the basic philosophy of swapping protection for mobility does not work in modern combat. The guns and firepower were always stronger than the armor meant the cars were tempted to fight, which caused scout vehicles to be used as light tank destroyers, a job they could not handle. The speed and firepower advantages were wasted because the armor could not keep crews safe against normal infantry weapons. Units using these vehicles suffered losses too high for ongoing operations," Major Hammond read the draft, and wanted Thornton to soften the words. The War Office wanted technical data, not critiques of German tactics. Thornton refused. The numbers told the truth clearly. You could make the fastest, most agile scout car in the world, but if the armor could not keep the crew alive when they used it fully, you just made a very expensive way to kill your own men. The report was filed and sent out. Thornton thought that was the end of his work, with the Sd.Kfz 234. He was wrong. The British kept to. Several captured Pumas in working condition at Churchy and at the Fighting Vehicle Design Center at Chobham. They were too valuable as reference standards to be scrapped or put on display. When British designers started developing the Ferret Scout car in 1952, they used the 234 suspension design as a baseline. The German car's independent swing arm setup, with 8 inches of travel per wheel, was still better than anything in British service. Daimler engineers studied it closely and used parts of the concept while simplifying the mechanics to make it cheaper and easier to maintain. When Alvis began designing the Saladin armored car in the mid-1950s, the team requested access to the captured Tatra diesel engines at Chobham's. The air-cooled V12 had shown it could survive temperatures that destroyed normal engines. British diesel technology had improved a lot in the 10 years since the war, but the Tatra's basic design, the cooling system, fuel injection, and power-to-weight ratio gave key ideas for Alvis's engine and drivetrain choices. The Sd.Kfz 2343 that Thornton tested in May 1945 stayed at Chobham until 1962. It took part in mobility tests against every new British reconnaissance vehicle, the Ferret Scout. One in 1952, the Saladin in 1958, and the Fox prototype in 1961. In every trial, the 17-year-old German vehicle was faster cross-country and handled obstacles better, but every British design learned the lesson the Puma taught. You could have speed, you could have firepower, you could have protection, but you could not fully optimize all three at the same time in a light reconnaissance vehicle. The British chose protection. The Ferret only had a machine gun, but gave the crew armor against rifle fire from any angle. The Saladin carried a 76mm gun, but weighed 11 tons with up to 32mm of side armor. The Fox had lighter armor but mounted a 30mm cannon chosen so crews would not be tempted to fight targets they should avoid. The design philosophy had changed completely. Speed was still important. Firepower was still needed for self-defense, but protection became essential because British designers had learned from German casualty reports. What happened when crews sat behind 8mm of armor with guns that could kill tanks? The temptation to fight was too strong to control with doctrine alone. The vehicle itself had to enforce restraint, either by limiting firepower or giving enough armor. The Puma did neither. The Tank Museum at Bovington acquired the Sd.Kfz 2343 from Chobham in 1962, when the testing center retired it from active trials. The vehicle was restored to running condition and placed in the Conservation Center, where it remains today. Visitors tap the side armor and hear the hollow thunk of thin steel. They see the 75mm howitzer sitting in the open fighting compartment. Then they look at the armor. The contradiction is obvious and striking, even for people with no military experience. The museum sign reads, "Captured by British forces in working order, May 1945, used for mobility trials until 1962, represents the height of German wartime wheeled vehicle development and its limitations." Thornton never saw the vehicle again. After finishing his evaluation in June 1945, he was promoted to major and moved to the War Office, where he spent 3 years helping develop the doctrine for post-war British reconnaissance forces. His report on the Sd.Kfz 234 was cited many times in discussions about armor standards. The question became shorthand for the debate: would you want your son behind 8mm of steel when shooting starts? The Germans were right about mobility. The Sd.Kfz 234 could outrun, outmaneuver, and outdrive any Allied wheeled vehicle during the war. The Tatra diesel was more reliable than British or American engines. The suspension handled terrain that broke other vehicles. The 8-wheel system gave redundancy. And traction 4-wheel designs could not match. The engineering was brilliant, but speed is not armor. Firepower is not protection. And brilliance and execution cannot overcome a flawed premise. The real genius was not in the engineering. The real genius was in seeing the problem and learning from it before making your own version of the same mistake. British designers at Chobham and Cheesy did not laugh at the Puma because it was bad. They studied it carefully because it was excellent. But they understood that being excellent in mobility and firepower meant nothing if the crew died in the first fight. The lesson cost the Germans about 320 Pumas and roughly 1,000 trained crew members. The British learned it by reading German casualty reports instead of suffering their own. The Sd.Kfz 234 proved that in armored warfare you can design everything except the moment when speed stops mattering and bullets start flying. That is the moment when armor thickness decides who goes home and who stays on the battlefield forever.